When we talk about mole concepts, we are looking at an idea of mole in calculation of particles that we have in any chemical substance. Now we know that atoms are very small. These are, we say that atom is um, the smallest particle of an element which can take part in chemical reaction. Because they are very small, scientists decide to devise a means of, measuring all these things. And that's how we come about with what the concept of mole or the idea of what mole. Now, this idea help us understand that one mole of a substance is the amount containing as many elementary units as the number of atoms in exactly 12 grams of carbon 12. Now, what does this really mean? Elementary units. What does this mean? Now, what it simply means that these elementary units could be ions, it could be atoms, it could be molecules. So a mole is like a collection of atoms, gathering them together, like what we have in a crate of an egg. So the egg is inside the crate. So in this crate now, that crate, as we call it crate, so in the same way we call mole that collection of that atoms. Atoms, ions is what we call the word mole. Now we also, according to Avogadro's number, we're meant to understand that for carbon, this carbon atom, um, 12 grams of carbon 12 contains what we call Avogadro's um, number, which is 6.02 times 10 raised to the power 23, which is Avogadro's number. Now, just like as we have already established the fact that a crate is just as similar as what we call a mole, which gather all of them together, gather all the ions, all the atoms together. In the same way, in that crate of egg, what we have there is in a crate of egg, we have what 30 eggs. So in the same way, in one mole, according to Avogadro's, we say that for one mole, what we have in every one mole, if we are talking about atoms, that means for every 1 mole of atoms is equal to what? 6.02 times 10 raised to the power 23. If we're talking about molecules, for each molecule we have, each 1 mole of any molecule also contains the same number, which we call what? Avogadro's number. Now, this mole altogether we're talking about, when we express it in grams, then we say is what? Molar mass. That is, 1 mole is equal to, or molar mass is equal to the mass of 1 mole of any substance. I believe that this is going on. It's getting me. So now that is where we are now. So again, another thing I want us to look at now. I want us to look at the relationship. Look at the relationship they have, what they have in, or how they relate to each other. How do they relate to each other? That is what we're going to look at. That is to say, if we have a mole here, this is a mole, then a mole contains, let's say, molar mass, and then in the other side of it, we also have 6.02 times 10 raised to the power 23, which is Avogadro's. The mole contains this, and this other one is equal to 1 mole, and a mole is equal to this molar mass. 1 mole is equal to molar mass, and molar mass is also equal to 1 mole. So here, molar mass of any substance also contain what? The Avogadro's constant, which is 6.002 times 10 raised to the power 23, and then also equals to what? Molar mass. So now, if we're talking about something like sodium, if we're talking about sodium, it means that 1 mole of sodium equals to what? 23 grams. We're expressing it in grams now because a mole contains the number of particles contained in a mole is equal to its relative molecular mass or relative atomic mass, as the case may be. So now, what it simply means here is that for this sodium in question, we're talking about sodium. For this sodium that we know that has a relative molecular mass of or atomic mass of 30, 23, if we express it in grams, that is what we have. Expressing it in grams, it means that 1 mole is equal to what? 23. And this 23 also equal to what? Is also equal to what? 6.02 times 23. This is the major basis of what the mole concept we are always talking about. And if you are watching us this moment, I want to encourage you to relax, calm down, and watch this video to the end of it, because I'm going to show you how you are going to be using the methods of doing this calculation that has to do with mole concepts. We're going to look at how we can apply it in what calculation. And if you're joining us for the first time, I'm going to encourage you to subscribe, and then make sure you share. Let your friends know about this so that they will also enjoy with you. So let's continue as we get along. We have already established the fact that a mole equals what? Molar mass. That's when we're expressing in grams, and then it also molar mass also equal to what? Mole. And here we have it that 1 mole contains Avogadro's number of particles. That is 6.02 times 10 raised to the power 23. And then also, and this Avogadro's equals what? 1 mole. So in this case, if we are to do the calculations, if we are to be calculating these things, we are going to look at some calculation that will help us how we can apply each of them, how can look at this relationship and use it in doing a lot of calculations. So that is what we're going to be looking at now. Let's see some calculation we can do here. Now we have some questions we're going to be looking at based on the topic we are looking at. We have already established the fact that mole concept is just a method scientists, apply or use in what measurements of chemical substance. They are very, very small in measure. So let's look at what we have on the board here. We have some series of questions, but the first question here says that what is the molar mass of molar mass in gram per mole of a substance if 0.4 mole of the substance has a mass of 25 grams. Now here we want to find the molar mass. I'm going to be solving it. I'm going to be solving it in two different ways, and then you can choose the one that is very, very okay for you. So the first method I'm going to use here, I'm going to be comparing it If I compare that together, we know that what the statement here said that one mole, 0 point, from the statement said that 0.4 mole of that substance contain this mass, So by the relationship we have, going to that relation, we know that mole equals what? Molar molar mass. Molar mass, and molar mass also equals um, a mole. And we know that for one mole equals what? This molar mass of any substance we're talking about now, they are equal. So if they are equal, now based on that, we know that one mole of this, 0.4 mole equals what? 25 grams of that substance we're talking about. Now, what will the 1 mole be? Because 1 mole is equal to the molar mass. We know that 1 mole is equal to molar mass. 1 mole now, which is equal to molar mass, what will it be? What it simply means is that 25 over 0.4 times 1 over 1. So what it's going to give us, now will be, okay, let me use calculator. So let's use calculator for this. So 25 divided by 0.4, what we have is 2.5 gram per mole. That is what we have. Because we are now comparing them. Comparing this. Now, another method of using it, another method of solving this problem, which is the one we can use the formula. In the formula, we know that mole is equal to mass over what? Molar mass. If it's so, our mole, in this case is what? Mole is equal to 0.4, and the mass given to us here is equal to 25 grams, and the molar mass is what we are looking for. Molar mass is what we don't know, which is question mark. So if we substitute all these things, values given to us, we have mole to be 0.4 equal to mass, which is 25, all over molar mass. Let me use ml in this case. So the molar mass is what we don't know. If we cross multiply it, we'll have it to be 0.4 and equal to 25. Now which is our molar mass, will then be 25 over 0.4. That will give us something as 2.5 gram per mole. And see that everything we're able to get exactly the same thing again. So let's look at the second question here. The second question, we have what is the amount of gold present in 16.5 grams of a pure gold wedding ring? We have the relative atomic mass of gold to be what? 197. So with that information given, let's see how we can tackle this problem. In working with this, we know that amounts. Okay, amounts now. We're talking about amounts, which is something as mole. So if it's so, what we're going to do here now, we know that let's go by that. We know that mole is equal to mass over what? Molar mass. So now the mole is unknown. We don't know the mole, which is the amount. We don't know this mole, but we know the mass. The mass given to us is 16.5 grams, and the molar mass, if we express the relative relative atomic mass of that in grams, we have the molar mass, that is gram per mole. So by substituting that, what we have will be equal to mass. What will be mass? That is the mass, which is 16.5 all over what? So what we'll get here will be 16.5 divided by 1. That will be equal to 0.0008. Let's say for approximately, that will give us moles. That's the amount. That's the amount of what we're looking for. So the next thing we are going to be doing here, will be, the next thing we are going to be doing is to solve the next one we have. So given that 0.02 mole of anoside N2 oxide, M-2 oxide weighs 1.24 grams. Calculate the molar mass and relative atomic mass. So what are we going to do here? This one I did not solve it the other way around. So from here we know that the amount, let's try it the other way before we go to the next question. So since we have, let's try this one the other way around. We know that this amount, and we know that 1 mole, we know that 1.7 gram of gold contains 1 mole. So 16.5 grams of gold will be equal to 1 over and 16.5. You also arrive at the same thing, approximately 4 mole. If you go by that, that's another method by comparing. If you compare them. So now let's quickly go to this next one we have here. In this question we have here, we are going to be finding what the molar mass and the relative atomic mass of the element we have there, which is M, which we don't know. So by this, what we're going to do now, we know that from just like what we did in the first place, we know that 0.0 mole of the oxide equal to what? 1.24 grams. So now 1 mole, because remember that we know that 1 mole of any substance is equal to what? 1 mole of any is equal to their molar mass. Because we're looking for the molar mass. 1 mole will then be, of the other will then be 1.24 over 0.2 times 1 over 1. So by going by this, what we have will be 1.24 divided by 0.2. That will give us, what we have will be equal to 62 gram per mole. So solving by the other methods, solving by the other method, we can use the molar mass. If we use the molar mass here, and the formula, we have mass over what? Molar mass. Now the number of moles we have is what? 0.02. The mass we have there is what? 1.24, and the molar mass is what we don't know. The molar mass is what we are looking for. So if we cross multiply, what we have will be, generally everything coming together, making molar mass the subject of the formula. We have 1 point all over 0.02. That will come back at the same thing that we have here. Gram per mole. That is what we have. So this case, we will be able to get this thing done. The second question we're going to be solving here is that say that relative atomic mass of M, relative atomic mass of M. Now, before we can do this work, before we can do this, then we're going to employ the relative atomic mass of oxygen. We know that the oxide in question is, and then we know that oxygen is what? Oxygen is 16. Then M is what we don't know. We don't know this M. We put question marks. So now we know that since if we are to calculate the molecular mass, if we are calculating the molecular mass now, what it will give us is that we know that it simply means that 2m plus what? Oxygen, where m is unknown, 2 times m is unknown, oxygen we know is what? 16. That will give us the molar mass equal to 62. And that's what we have. 62. So the next thing we are doing here is also 62. Then collect like terms. We find out that 2m will be 62 minus 16. 2 minus 16. Here we have this will give us 12. We subtract, we have 6. The other one we minus, we have this one will be 4 now. So what we have here will be 4. So m will then be 4 6 divided by 2. 4 6 divided by 2, that will give us, this will be 2, this will be 3. That means m is equal to 23. That's the relative atomic mass of this. So we're going, the next question we'll be looking at how we're going to be working if we are trying to find the number of particles. The number of particles that we're going to be looking at. I want to encourage you to watch and pay attention as we get along with this. So here we are going to be calculating. Remember, like we stated earlier on when we started this video, we were able to understand that Avogadro's number gives us the number of particles in every substance, chemical substance. In every chemical substance, the number of Avogadro's is equal to the number of particles that we have in 1 mole, and also in each molar mass of it. So each molar mass I'm sorry. Each molar mass contains, the molar mass of any substance contains Avogadro's particle, and also equal to, the molar mass is also equal to 1 mole. It's also equal to what? 1 mole of that substance. So based on that, this question we have here says that we should how many atoms are in 4 grams of calcium? 4 grams of calcium. Now, but we know the first thing we need to look at this. We look at that relationship that we have, where we have mole, 1 mole, a mole equals to what? That means 1 mole equals that. Then we also have molar mass. Molar mass. Depending on what we're looking for. In this other case now, what we have is relative atomic mass of this calcium if we express it in gram, that is to say that 40 grams, we can also move it to we can also change it to mass unit. Hmm? Can call it mass units. Just use that. So the mass of this now. So what we have here, since we know that this mass, that 40, from here we know that we don't know the number of particles that we have in 4 grams, but we know that for 40 grams of calcium, we have 0. In 40 grams of calcium, we have 0.6.02 times 10 raised to the power 23. That is what we know. This is a statement of fact. So since we know that, what will this other one be now? This 4 grams. What will these 4 grams be? 4 grams. What is it likely to be? Then what we do now is that 6.02 times 10 raised to the power 23. 23 all over 40 times 4 over 1. So what are you doing here? I think this one can go. We have 1. This one gives us this. So what we do here, it will be like, okay, from indices, we can say that this point what? 0.02 times 10 raised to the power 22 atoms. Atoms, that is what we have here. That's the number of atoms that we have. So let's go down to the next one. The next one said that what mass of 6.02 times 10 raised to the power 26 atoms of magnesium. What is the mass of 6.02 times 10 raised to the power 26 atoms of magnesium? So what we are going to do, how do we solve this problem? Let's quickly go down to that. So what we know that for every mass, we're looking for the mass now, and we know that for the atom, for this atom, this very atom we have, if we're looking for, yes, so we have 6.2 times 10 raised to the power 23 of magnesium has what? 24 grams. So what we have is we're looking for 6.02 times 10 raised to the power of magnesium will then be 24 over 6.2 times 10 raised to the power 23 multiplied by 6.02 times 10 raised to the power 26 all over 1. I think this can go, that one can also go. So what we have, let me use indices. So how will then be so 24 will give us 10 minus 23. So if this subtract that, we have 3. I think it will be 24 times 10 raised to the power. This subtract will have 3 raised to the power 3 grams. Since we are looking for gram, that will be like which is something as 24,000 kilograms of what? Magnesium. So this is where we're going to stop this our calculation for today. Thank you for being part of the class, and we want to encourage you to subscribe if you have not subscribed, and then like. If you have any question, you can leave your question in the comment section, and we can always attend to you. Thank you so much.